Good day, my viewers. This is Ayodele Samuel Jude, the founder of Smart Tutorial platform on Facebook. This channel, Samuel Dino, is always there for you to give out the basics that you need to know in your various subjects as students, as parents, and as teachers. Also, school owners can always subscribe to this channel to always get one or two things that you can use to improve your student performance. Don't forget to just click the subscribe button so that you get all our latest video anytime we upload them on this channel. The subscribe button is there. Just do that now. Just click on it. It's free. Just do that. Thank you. After the video, if you like the video, you can always like, send your comments, and don't forget on our assignment or classwork, you can always solve it, take the picture, send it to upload it as comments on the Smart Tutorial platform on Facebook. Smart Tutorial, just go there, upload, either you upload it as comments or as a post, we approve it. This video is actually based on request of one of my students who sent me a question due to distance. He said, why is CO named differently from CO2? So I just say, okay, let me just make a short video. I'll try to make the video as short as possible, but if not, there's nothing we can do. So this video will be based on CO, CO2, CO3 2 minus, and C, carbon C itself. So why is the name different? One of them is carbon 2 oxide, one is carbon 4 oxide. Why is it named like this? Why? As in, the funnest part is that this one is having 2 oxygen. You didn't call it carbon 2, you say carbon 4. This one is having just 1 oxygen, you call it carbon 2. So why is it like that? This thing happens to so many compounds also in chemistry. So you have to know the basics, and the basics is just the IUPAC nomenclature. That is the naming system. The International Union of Pure and Applied Chemistry system of naming compounds, so that it will be generally accepted by all, irrespective of your location in the world. So one of the system is the stock system. So the stock system makes use of the oxidation number to name some compounds, especially the inorganic compounds. Compounds like CO, you have to calculate the oxidation number of carbon. If it is another compound, you have to take note of the central elements. The central elements in that compound, that is what you have to calculate. That most of the central elements, they are always made up of elements that have various oxidation number. So when you are able to calculate the oxidation number, then it will help you to name confidently some compounds. And here I'm going to base the video on how to calculate oxidation number. Then from the name, you'll see that the oxidation number of that central element reflected in the name of that compound. Now let's start with this. When you want to calculate oxidation number, that is the oxidation state of any compound or any elements or ions, you just have to equate the whole compound or ions or elements to the power of what you see. Let's take, for example, this is CO. Nothing is on the power. Here, nothing is on the power. That means it's 0, 0 equals to 0. Everything equals to 0. Here we have -2. So here will be what equals to -2. And also another thing you have to take note when you are calculating the oxidation number is that oxygen is -2. The oxidation number of oxygen is -2 anywhere, anytime. Oxidation number of hydrogen is +1. Also, as a student, try to take note of the oxidation number of the first 20 elements. The group 1 is +1, group 2 +2, group 3, all the elements in those group. 1 + 2 + 3 + 4 + 5 + 6 + 7 + 8 + 9 + 10 + 11 + 12 + 13 + 14 + 15 + 16 + 17 + 18 + 19 + 20 + 21 + 22 + 23 + 24 + 25 + 26 + 27 + 28 + 29 + 30 + 31 + 32 + 33 + 34 + 35 + 36 + 37 + 38 + 39 + 40 + 41 + 42 + 43 + 44 + 45 + 46 + 47 + 48 + 49 + 50 + 51 + 52 + 53 + 54 + 55 + 56 + 57 + 58 + 59 + 60 + 61 + 62 + 63 + 64 + 65 + 66 + 67 + 68 + 69 they are in that order. Group 3 is +3. Then group 7 is +1 and -1. So when you know the valence electron, that is the electron at the outermost shell of those elements, then it will help you to know the oxidation. You can determine the oxidation number of those elements from the valence electron, if provided that they are part of a compound. Provided that they are part of a compound, that is, any element that is not in a compound form, that is not part of a compound, the oxidation number is 0. And this is what I'm going to show you in this question number 4. That is the power here. Nothing is on the power. So is what is equals to 0. So what do you want to calculate here? Nothing. So the oxidation number of carbon or any element that stands alone is what? 0. So the oxidation number of a neutral element is what? 0. Now let's look at the first one, CO. CO, we have CO, the power is 0, just equate it to 0. Then C, we are looking for the oxidation number of carbon in the following. So oxidation number of oxygen is -2, -2. So we have to put brackets here to protect the -2 equals to what? 0. So if you do your calculation very well, you will end up with this. Then carbon equals to what? This is equation already. -2 to this side is what? +2. So the oxidation number of carbon is what? +2. So if you want to name this compound, is what? Carbon 2 oxide. So that is the compound is what? Carbon 2 oxide. So that is the reason why this one is called carbon 2 oxide. This one also, the power here is what? 0, equals to 0. Then from what we have here, oxygen itself, oxygen is -2, -2. But this 2 is different from this 2 is for the oxygen, but this is the -2 is different from this 2. So this one will be what? That is, each of the oxygen, that will be times 2. What simply means is that one oxygen is -2, but the oxygen we have here is 2. So that is why we have -2 times 2. We have 2 oxygen here. So one of the oxygen is -2. So we now have what? Times 2. Sorry, you add each of the oxidation number together. So this one is for the oxygen, carbon and oxygen. This is carbon, this is for the oxygen, equals to what? 0. You form an equation from what we have here, then solve the equation. That is, this one will give us what? -4 equals to what? 0. Then C, if you open the bracket, you get -4 equals to 0. C is equals to what? +4. So this compound, CO2, is what? Carbon 4 oxide. Carbon 4 oxide. That is just it. For this one, this is an ion. Is an ion on it. Is an ion. That is, the power is what? -2 equals to what? -2. So the C, we are looking for the oxidation number of C. Oxygen is -2. How many oxygen do we have there? We have 3 oxygen. This -2 is for all of them. That is why we said equals to what? 2. So oxygen -2 times what? 3. Which is what? Equals to -2. So C, that will be what? Into bracket -6. -6 equals to -2. So from what we have here, we now have what? -6. If you open the bracket, equals to what? -2. C is equals to what? -2. The C will cross to this side and become what? The 6 -6 will cross to this side and become +6. So we now have what? +4. This is just equation. So the oxidation number of carbon here is what? 4. The oxidation number of carbon here is +2. The oxidation number of carbon here is +4. The oxidation number of carbon here is 0. So, but to answer my student question now, the oxidation number of carbon here is what they use in the IUPAC naming system to name CO and CO2. So that is why it is what carbon 2 oxide, carbon 4 oxide. I'm just trying to make the video to also explain oxidation states. Sorry. So just to add to the example under the oxidation number, like I said, you have to know some oxidation number offhand, like the oxidation number of the first 20 elements, which are the group 1, group 2, group 3, and possible group 7. You have to know this the oxidation number of the elements in all these group 1, group 2, group 3, and group 7. You have to note the oxidation number. So because actually some of the elements, some of the oxidation number of some elements will be given in the question, so you don't need to panic. But what about a situation where they are not given? You should be able to know the oxidation state of melters. So here we are asked to find the oxidation number of calcium and sulfur. Calcium and sulfur. Here the oxidation number of hydrogen and oxygen is given. So from what we have here, so we now have what? Calcium, the power is 0. Here the power is minus, that is -1. So that is what? Calcium plus bracket, oxygen is -2, 1 oxygen, plus hydrogen is +1. Only this one is multiplied by 2. The 2 is for only oxygen and hydrogen, that is times 2. Everything equals to the power, that is what? 0. So from what we have here, we now have what? Calcium plus -2 plus 1, that will give us -1 into bracket 2 equals to what? 0. So calcium, from what we have here, will now be what? Will now be what? -1 times 2, that will be what? -2 equals to 0. So calcium will be what? If you open the bracket, you get -2 equals to 0. So calcium now equals to the -2 will come to this side and become what? +2. So calcium here is what? 2. But don't forget, calcium here is not the central element. We are only asked to calculate the oxidation number of calcium here. And I told you earlier that melters in group 1, 2, 3, they have stable oxidation state. So that is why it's easy for students to know this oxidation number of elements in group 1, 2, 3. Unlike this, sulfur has various oxidation number. So that is why it is essential to know that if you look at most of the compounds that contain sulfur, you discover that sulfur is always at the center, is the center element. Is the center element. We have sulfur 2 oxide, sulfur 4, sulfur 6. So like that. So from what we have here, I'm just trying to use this example to tell you, to explain how to calculate oxidation number of some elements if they are in a complex form, like this, the one of this bracket, and this one is having minus on top. So like I said, always equate it to the power of what you have on the element or on the compound. This one is a compound, is an ionic compound. So sulfur will be what? SO4 equals to what? -1. You equate everything to the power, which is -1. Then that will be what? Sulfur plus how many oxygen? Oxygen is -2. Don't forget. Then oxygen is how many? 4 times 4. So equals to -1. So from what we have here, I didn't write this very well. I'm sorry. It's -2. It should be 2 minus. I was very fast. I just discovered that this one is 2 minus. So from what we have here, We now have what? S plus, this one will be what? Minus 8, then minus 2. S minus 8 equals to minus 2. So S is equals to what? Minus 2 plus 8. At the end of the day, S will be equals to what? Plus 6. So this compound, this sulfur is what? The oxidation state of sulfur is plus 6. Is plus 6. The oxidation state of sulfur is what? Plus 6. What I'm trying to point out here is that if you look at the name of this ion, that will be tetra also sulfate. Sulfate what? 6. Sulfate 6. Sulfate 6 ion. Sulfate 6 ion. So that is just it. So the central elements, that is the central elements, is what they will always ask you to do justice to the oxidation state. So don't be panicked as a student when you are asked to calculate oxidation number. They will mention the name of the element you are to calculate. That is just it. And sometimes they will give you the oxidation number of some of the elements. Don't be confused. Don't be confused. Okay, let's look at this question. If you are asked to calculate the oxidation state, oxidation number of calcium in ordinary calcium, what will you do? And here you know that calcium is plus 2. This calcium is different from this. This calcium here is form a compound. This calcium here is on a free state. Forget about the plus 2 that you have gotten here. Forget about the valence electron of calcium. Just focus on what you have at hand. That is, the power is what? Still 0. Nothing is there. So is what? 0. So the oxidation state of calcium is what? 0. So just for you to practice at home, try to do the pause the video and write down this question and solve the elements that are encircled or that are being underlined. Solve the oxidation number of those elements. It will help you at home. Make sure you practice as students. Practice and practice often. So we also have some other questions that can help you. Just solve them, take picture of them. You can always send it to under the comment section, or you send it to Smart Tutorial. It will help you to know whether you are getting it, and also it will also help some other students that are shy to submit their questions. So you can always send the picture, take the picture of what you have done, send it as comments, send it as post. We will approve it, provided it's very educative. Don't worry, don't be shy, don't be scared to make mistake. Try to make mistake and learn from it. So we always be there to help you out. For private lesson, you can always message us on the numbers on the just message us on Twitter, as in on the Facebook. We'll always be there to guide you. Thanks for watching. Don't forget, the subscribe button is there. Just click on it. It's free. We'll always be there to help you free of charge. Thanks for watching.